लाइव हो गया क्या? Hey guys, is it live yet? Please tell me. So I believe I am live now. Hey guys, good morning. Good morning everyone. Good morning Sanjay. Good morning Arunopal. कैसे हो भाई, कैसे हो? सिर्फ दो लोग दिख रहे हैं, कहाँ है बाकी? जल्दी आओ भाई, जल्दी आओ। सीक्वेंसिंग मॉडल 2 का क्लास स्टार्ट करें। Guys, come on, hurry up. We need to start the second lecture of sequencing model. Good morning कुरहड़े जी। Hello Ashok. Ashok, I believe this is your first class. I have never ever seen you commenting in the live chat. So I believe this is your first class. Hello Neelaj. Hi, good night. Okay. So I think everybody is coming up at its own time. So guys, let's not waste any more time. And straight away. Pranam Ajay, Pranam. So let's not waste any more time and let's just straight away get into a bit of details. For those who don't know me, my name is Manish Mishra. I secured an all India rank of 568 in GATE 2015. And since then, I have been teaching GATE and ESE aspirants. I have a cumulative experience of 5 years in teaching. And the subjects that I primarily take are manufacturing science, industrial engineering, operations research, and material science. Okay. So guys, this is my profile. Okay, Ashok, no issues. Welcome to see you. Okay, Ashok is saying he saw my recorded class. Very nice, Ashok. Welcome to this live session. Okay, so let's dwell into the same spot where we left the class yesterday. So let me just straight away jump into that. So guys, basically in the last class, we completed the n job one machine problem. Through one machine problem. Now in today's class, I will be jumping straight away into the n job 2 machine problem. Okay. So what is an n job 2 machine problem? In yesterday's class, I told each and every one of you that this is a very important topic as far as the GATE examination is concerned, because if you will check out the previous paper, you will notice that from this particular area, questions have appeared in the GATE paper. So I must say that this particular topic under the sequencing model, that is processing n jobs through two machines, is very very important. Okay. सर मैंने आपसे व्हाट्सएप पे पूछा था कुछ। अजय क्या पूछा था? अच्छा अजय मैंने आंसर तो किया था। आई थिंक आई हैव आंसर्ड। अब उसके आगे शायद कोई तुमने मैसेज किया होगा तो मैंने ध्यान नहीं दिया, बट आई थिंक आई हैव आंसर्ड योर क्वेरी वाया वॉइस मैसेज। Ashok is saying, now I feel the subject, sir. Thank you, Ashok. Thank you. That's very nice of you. तो कोई नहीं अजय, एक बार फिर से पूछ लेना यार। 2 बार पूछ सकते हो तुम। चलिए स्टार्ट करता हूँ, है ना। कुछ लोग और आ जाएं, बस उसी उसी चीज़ का इंतज़ार कर रहा हूँ, सो दैट दे डोंट हैव टू वॉच द recorded lecture. That's why I am delaying. I hope you guys don't mind. So okay. So guys, let me first tell you, let me first of all tell you, अजय इज आस्किंग सर मैन्युफैक्चरिंग या मटेरियल आपने कहीं लिया है क्या? अजय, आई हैव नॉट टेकन मैन्युफैक्चरिंग और मटेरियल साइंस अप अंटिल दिस टाइम on the Unacademy platform, but yes, after industrial engineering I will be starting a series of manufacturing and as well as material science, and that will be on the special classes, and it might come on YouTube also. Okay, so I guess everybody is here in the class right now. And one more thing everybody, in today's class I will be needing you all. Okay, I mean in today's class there will be a situation where I will need each and every one of the students who is watching this lecture live. Okay, so just do one thing. I have already seen the names of those people who have already commented on this particular live session. But those who haven't commented, just please comment in the comment box or in the live chat section, so that I know that if somebody is attending, I may see his or her name. And yes, that will be very, very essential for me in today's lecture. Okay, I will be doing something with respect to a question, and for that I need each and every student, and I have to see each and every other one's name. Where is Ashwin? Where is Sanjay Gupta? I mean, some of the students are missing from today's lecture. So, okay, no issues. Let's just jump into this. So, guys, first of all, understand what is an n job 2 machine problem. What is an n job 2 machine problem? In the last class, I took an example of n job 1 machine problem, where basically I told you that there could be multiple jobs with different processing times, with different delivery dates, but there will be only a single man or a single machine to perform the operation. There will be a single man or a single machine to perform the operation. But in this case, it's not like that there will be n number of jobs, but there will be 2 machines. No, that is not the case. It is a bit more specific, or I would say it is a bit different. So let me just explain this to you guys. Okay. So guys, suppose there is a manufacturing job. There is a manufacturing job where, let's say, you have to create one bolt. Okay, so how does a bolt look like? Let me just try to draw a bolt here. I hope I can justify the look of the bolt with my diagram. I will try to do so. This is how a bolt should look like, let's say. Okay, so just consider this a bolt. Okay, so if I will manufacture this bolt, what I will be doing, let's say I will take a solid shaft, and then via the turning operation, what I will do, I will simply turn out this much material that I am shading in black color. I will simply, using the turning operation, I will simply remove away the material that I am shading in black, and then what I will be doing, let me do that in red color. Then via performing the threading operation, I will provide thread on this bolt. Okay, so if I want to manufacture this bolt, the number one job that is to be done is turning, where I reduce the outside diameter of the solid shaft. and the second operation is threading, where I make the threads or the pitch on the bolt. Okay, so guys, if you want to manufacture a bolt, remember the first operation that you should be performing is turning, and then you will be performing threading. It cannot be the inverse. It's not like we can perform threading first and then turning. Okay, that should not be the case. Otherwise, there will be a different product that will be produced, and that will not be a bolt. Okay, so first of all we need turning, then we need threading. So basically what is happening here, that there is a job like to manufacture a bolt, and to manufacture this bolt we need two different machines. That is one a turning machine, the other one is a threading machine. Let's just consider this situation or take this example. So all I'm trying to explain here is that an n job 2 machine problem is something like this only. There can be n number of jobs. I can say there could be n types of bolts with different dimensions, different diameter, different thickness, different pitch, everything, material different. But remember, there could be n jobs with different processing times. 10 types of bolts with different processing time of manufacturing time of all the bolts. But remember, every bolt should go through these two machines, and that too in a proper sequence. First we will be performing the turning operation, and then only we can perform the threading operations. So all the jobs that we intend to produce, each and every job must go through both these machines in order to finish the job. And the operations sequence should be such that first we will be performing the turning operation, and then we will be performing the threading operation. So guys, now what I have simply mentioned what I have told you just now with the help of the example. That is what is written here in this paragraph. I am not going to read out this paragraph to waste your time. I am just straight away going to take the question and start dealing with it, and then I will come back to this part and explain it to you so that you can grasp it very easily. Okay, so let me just move on to that. So guys, what it says that whenever you get a problem of n job 2 machine, the problem will look something like this. There will be a row or a column where the jobs will be represented, like job 1, 2, 3 up to let's say job n, and then there will be two machines, machine A and machine B, and the processing time of these jobs on these machines are represented under this column, that is column A and column B. Similarly, for all the jobs, their processing times are mentioned here. And remember, there is always a sequence. First, I will have to perform the job on machine A, and then only I can perform the job on machine B. Okay, so that is the sequence. But remember, these times can be different or can be same also. Suppose I say this A1 is 2 minutes, this A2 is 3 minutes. So job 1 will require 2 minutes time on machine A, and it will require 3 minutes time on machine B. The bolt number 1 will require 2 minutes time for the turning operation, then 3 minutes time for the threading operation. So guys, I hope you are able to understand whatever I am saying. Okay. So now the entire idea in this sequencing module is to find a particular sequence which can optimizes the resource that we have. Okay. In the earlier class, we did the same thing. Whatever resource we have, whether it is our time, whether it is the labor, the man hours, the machine hours, whatever it is, the entire objective of sequencing module is to provide you with a sequence, to provide you with a order or arrangement in which the jobs should be handled so that you can optimize whatever resource you have. So here in this case again, for an n job 2 machine problem, the entire objective is to optimize the total duration in which these jobs can be performed. So for that, we make use of Johnson's algorithm. Okay, this is very important. Johnson's algorithm takes charge to optimize an n job 2 machine problem by providing you with the optimal sequence. Let me just say this statement once again. Johnson's algorithm takes the charge in case of a n job 2 machine problem to provide us with an optimal sequence. Okay, so what basically Johnson algorithm does, let me just write this in terms of statement so that everyone can note it down. Johnson's algorithm reduces the makeup span and it gives optimum solution for makeup span. Okay guys, so I have written a statement here and the statement reads out as that Johnson's algorithm reduces the makeup span and gives optimal solution for the makeup span. So now I'm not going to explain this sentence just like this. Let us just deal with the question and then we will come back to this statement. Okay, but overall what I have explained up until this point, that in an n job 2 machine problem there will be two machines and all the jobs has to be processed on both the machines in order to completely process the job, and that too in a specified order. First turning operation will happen, then only we can perform the threading operation. Now, when it comes to the sequence of these jobs, that in what order, in what arrangement, in what sequence these jobs should be handled so that we can optimize the resources we have. For that, Johnson's algorithm will take the charge and provide you with an optimal sequence. So now let's just get into Johnson's algorithm. So this is a question here. I hope this question is clearly visible to each and every one of you. Okay. So this is the n job 2 machine problem. And in this problem there are 7 jobs: J1, J2, J3, J4, J5, J6, J7. And these jobs are to be processed on two machines, machine 1 and machine 2. And the processing time on each of the machines is specifically mentioned in the table. Sir, little bit Hindi also, feel अच्छा आता है. Okay Ajay, I will do that, but there are certain students who are from South India. They do not feel comfortable whenever I speak Hindi. But yes, I will try to do that. Okay. चलो बाबा, चलो सुनो. So n job 2 machine problem है. Now there are 7 jobs from J1 to J7 and the processing time of each of the jobs are mentioned here in these particular rows of machine 1 and machine 2. And remember, every job has to go through both the machines, both machine 1 as well as machine 2 in order to complete the job. सुनते चलिएगा, ठीक है ना, सुनते चलिएगा. Now let me just tell you what Johnson's algorithm is. So what you will be doing, ऐसा करेंगे आप लोग कि just take 7 positions, 1 2 3 4 5 6. Okay, so these are the 7 positions. Okay, 1 2 3 4 5 6 7. As there are 7 jobs, I have taken 7 positions. Now what I will be doing, I need to find a sequence in which we should be doing all these jobs in order to optimize our resources. So as you can see, there are 7 jobs. So I have taken 7 places, and now I will be filling these 7 places with these 7 jobs, but in a sequence which will be most optimal for me. And for that, I will be using Johnson's algorithm. Johnson's algorithm. Now, what is Johnson algorithm? The first thing that this algorithm says, सबसे पहली चीज जो ये algorithm बोलता है, listen to this. The first thing that this algorithm says, spot the minimum processing time across all the job on all the machines. So guys, in this case, there are 2 machines, there are 7 jobs, and I have to spot that particular processing time which is least on the entire table. So now if you will look into this, the least time available on the entire table is 1. Now what Johnson's algorithm says, क्या बोलता है Johnson algorithm? कि if this particular processing time, the least time, the minimum duration of all the durations available here, the one which is the least, if it is on machine 2, then process this job number 3, process this job at the very last. And if this particular minimum time is available on machine 1, then process this job first of all. I hope you are getting my point. Let me just tell you in Hindi also, because some students are asking, Ajay is specifically asking, क्या बोलता है जॉनसन एल्गोरिथम मेरे भाई कि आपके पास 7 जॉब है, 2 मशीन पे प्रोसेसिंग टाइम लिखे हुए हैं, दोनों मशीन के प्रोसेसिंग टाइम्स को देखो, 7 जॉब पे देखो, और जो सबसे आपको लीस्ट मिल जाता है, सबसे मिनिमम मिल जाता है, अगर वो सेकंड नंबर वाली मशीन पे है, नीचे वाली मशीन पे है, उस जॉब को सबसे आखिरी में करो, और अगर वो पहले नंबर वाली मशीन पे है तो उस जॉब को करो सबसे पहले. ओके, so listen to me. Now as we can see that for job number 3, 1 is the minimum time across all the processing times available on this table, and that too it is on machine 2. So guys, simply what we will be doing, we will be putting job number 3 at the very last on this sequence order. And once you have allotted job 3, once you have allocated job 3, just simply strike off this job. Just simply strike off this job. Now, look for the processing time. Look for the processing time which is the minimum at this particular moment. Look for the processing time which is minimum at this particular moment. Now, if you can spot, you will see that 2 here and 2 here. That is in case of job 1 and job 6. There are 2 places where we have the minimum value. There is a tie, tie, in between job 1 and job 6. And as you can see that the processing time is on machine 2. So these jobs, job number 1, job number 6, job number 1, job number 6, they have to be in the last position. I will take this job and put it in the last, in the sequence. I hope you all are getting my point. Just throw it in last. So now what I will be doing, both 1 and 6 are fighting for the same position. That is this position. Let me just mark this position. Both of them are fighting for this position. So what I will do, I will simply give this position to 6, this position to 1, and I will make one more sequence. I will write 6 here, 1 here, and 3 here. I hope now there is no issue. There is no doubt for anyone in this particular case. Neelaj Shinde has already given me the sequence. Neelaj, I don't want the sequence. Let me just tell you, because let me tell you, it is very easy to go through a textbook, understand what is Johnson algorithm, and can simply write this sequence. But what I will be telling you is what I have gathered over years of teaching industrial and OR. Okay, okay, Neelaj. Neelaj, I think your answer is right, but I am not looking for the answer, Neelaj. I am not looking for the answer. Just check this out. Just check this out. Okay, listen to me. Listen to me. So now what I have done, what I have done, because job number one, job number six, we are fighting for the same position. Let me do one thing. Let me do one thing. Let me just erase this part of one here and just strike this off, and let me just encircle these two positions because there was a tie. Okay, remember the red circles that I am putting will represent a tie. Okay, okay. Are Neelaj, no need to say sorry, my friend. No need to say sorry at all, man. Why are you saying sorry? I am not upset. I am just saying, just listen to this. Listen to this. Take it patiently. It happens to us whenever we know something in advance. We get excited, and in that we do not take that part which is necessary for us. We do not see those things which are necessary. So never ever get excited whenever you are studying, whenever you are writing an examination. Okay, so listen to me, listen to me. So now 2 is over. I have what I have done, because there was a tie between 1 and 6, and that too for this position. So I gave this position once to 6 and once to 1. Okay, and the other time to 1, so that both can take that positions at least one time. So now I will be striking off this and this job. Now if you will see, if I will tell you to find the minimum value will be 3. So this here and this here. It is on job 4 and job 7. But remember, on job 4, this 3 is on machine 1. So job 4 will straight away go to the first place. Okay, job 4 will straight away go to the first place, and because on job 7 it is on machine 2, so job 7 will occupy the last place. Okay, the last place. So that is of no concern. Although there are two values of 3, but this is not a tie, because these two jobs were not fighting for a single position. They will be fighting for a different position. So this is not a tie. That's why I am not going to encircle it. Okay, guys. Now let me move on. So once 4 and 7 are over, let me just strike them out. Now if you will move on to the next minimum value, the next minimum value is 4. And now you can see that for 4 there is a tie in between the same job on two machines. Let me just encircle this. Same job on two machine. Now guys, this particular job can be noob to pro in life YouTube. Sir, I am Ashwin. I am also live, but I cannot comment with that ID. I think I have got blocked or something. No worries, Ashwin. No worries, my man. You can comment with this ID on my class. Yes, your comment is visible. No worries, you can write with this ID. I will be calling you noob. So listen to this. Somebody by the name Saket Mishra is giving 100. What is this 100? Are you trying to bribe me? Saket? Who is this idiot? Who is this Saket Mishra? Guys, Saket Mishra is my brother. Okay, he is watching this lecture. I don't know why. I have told him specifically not to watch, but he is watching. So hi Saket. Everybody please say a hi to Saket if you can. So guys, let me just move on. So now for 4 there is a tie between machine 1 and machine 2 for job 2. So basically what we can do with respect to this 4 that is on machine 1, we can simply put job 2 on the first position, and with respect to this 4 we can put job 2 in the posterior position at the last position. So basically what happens, job 2 can either go here or can go here. So what I will be doing, I will put job 2 here first, then here first, And because of these different positions of job 2, because of this different position of job 2, what will happen, this will also get mixed up, this will also get mixed up. So I will get another sequence J4, J2. Let me just strike off J2 first, and J5 is the last one left. So let me just put J5 here and let me just strike this off as well. So J5 will come here. So J2, J5, J7, J6, J1, J3, and at last I will be writing J4, J5, J2, J7, J1, J6, J3. So guys, listen to this. Listen to this, listen to this, listen to this. ध्यान से सुनिएगा भाई, है ना, ध्यान से सुनिएगा, बाद में मत बोलिएगा सर ने बताया नहीं था. Listen to me very very carefully, otherwise don't tell me I didn't tell you. So सुनो. So guys, basically what I have done, I have formulated a sequence. But while I was formulating the sequence, there were two multiple occasions where I got a tie. Just look at this. There were two occasions where I got a tie. One when I have encircled the values in red color, and once when I have encircled the values in green color. Now in the case of tie, what I did, that 1 and 6, job 1 and job 6 were fighting for the same position. So once I gave this position to job 6, and the next time I gave this position to job 1. Similarly for job 2 was fighting for two different positions. Job 2 could have either gone at this position or at this position. So in one case I gave job 2 this position, in another case I gave job 2 this position. But because I can either place 5 or 2 in any of the position, then with respect to 6 and 1, there will be 4 combinations available. Okay, so what I have done, by keeping 2 in front and 1 in front and 6 in back, then again 2 in front, 5 in back, 6 in front and 1 in back. So this is the inverse of this. Okay, and again what I have done, by keeping 5 in front, I have kept 6 ahead, then again 5 in front and kept 1 ahead. So with respect to both those ties, I have created 4 combinations. So now I have got 4 sequences. 4 sequences. Okay. Now guys, listen to this very very carefully, and let me just tell you that the things that I am going to share with you, you won't be able to find this in any textbook. Okay, you won't be able to find this in any textbook. Just let me tell you this, because what is there in textbook, I have also noted this down here step by step, and I will be showing that to you. No need to worry about that. Whatever method I have told you here, I have completely noted down or written those methods in these slides. So I will be showing that to you in a moment's time. But just simply understand what is Johnson algorithm. It simply says that spot the minimum value, and if the minimum value is on machine 2 for a particular job, just do that job in the very last. And if that minimum value is on the first machine, do that job first of all. Do it in the front. Okay, so just by keeping this in mind, we have to find the sequence. I have not done anything else. Just in case of tie, what I have done, I have satisfied both the situations. In case of tie, both were fighting for a certain thing, so I gave those things one time to one of the job, another time to another job. Okay, so that way I have secured 4 sequences. Now if you will go by the method provided by the textbook, you can only locate one of the sequence. But guys, I say that using Johnson's algorithm, if I have obtained these 4 sequences, then all these 4 sequences are optimal sequences. And don't worry, I will be proving this to you. I will prove this to you that all these sequences are optimal sequences. Okay guys, listen to me very very carefully. अरे यार, listen to me ना. अच्छा सुन रहे हो क्या? You guys are listening. So now I am saying that all the sequences available are optimal sequences. How to prove that? How to prove that? So guys, now what I will be doing, let me just show you guys. Let me just show you guys. Very nice, Ashwin, nice try. Okay, so guys, now what I will be doing, let me just write the serial numbers: 1 2 3 4 5 6 7. So now, as you can see that we have obtained 4 sequences using the Johnson's algorithm. What I will be doing, that first I will be taking a very general sequence, a very chronological sequence, I would say, in chronology. 1 2 3 4 5 6 7. So what I am simply doing, I am taking a chronological order. I am not going to use any of the sequence provided by the Johnson algorithm. I am just simply targeting the jobs in the chronology: 1 2 3 4 5 6 7. So let me just note down the times. Let me just note down the processing times. So for job 1, 3, 2, job 2, 4, 4, then I have 8, 1, then there is 3, 5, 7, 7, 6, 2, 4, 3. So guys, these are the sequences, these are the processing times, and the sequence that I am using is the chronological sequence: 1 2 3 4 5 6 and 7. And what I have done, I have simply written the processing time of these particular jobs on machine 1 and on machine 2. Now guys, simply look at this, this is the first job. I have taken a stopwatch, and what I will be doing, I will be just noting down the times, the start time and the end time of these jobs. So now you can see that job number 1 will start at 0 and the processing time is 3. So after 3 minutes or 3 hours, whatever it is, it will end. So on machine 1, job number 1 will start at 0, end at 3. And remember, When I will complete the turning process, then only I can move on to the threading part. So now what I have done, I have started the job, and after 3 minutes I have completed the turning process, and once the turning process is over, I will simply switch this job to the threading machine so that the threading machine can start. And without wasting any time, I have ended the job on the third minute. I have simply put the job on the machine to the threading machine on the third minute, and as you can see, the processing time here is 2, so the machine 2 will process this job on 2 minutes time, and it will end the job in 5 minutes. So I hope this is clear to each and every one of you. I hope this is clear to each and every one of you. Now guys, remember job 2. Come to job 2. Now what you can see here, that job 1 was over, or I should say the job 1 got completed on machine 1 on the third minute. So on the third minute, I would say that the machine 1 is empty. I can start processing any other job on the machine 1 when I can see that on the third minute job 1 is over and machine 1 is empty. So what I will be simply doing, I will be starting job 2 on machine 1 on the third minute, and after 4 minutes time it will end on 7 minutes. Now guys, see, look at this place, look at this situation. Machine 2 completed job number 1 on the 5th minute, and as soon as the 5th minute is over, machine 2 is free. Machine 2 can start the job on the 5th minute as well. But guys, unfortunately, job 2 is getting completed on machine 1 on the 7th minute. The turning process is completed on the 7th minute, and remember, without turning it, we cannot perform threading. So 7, although this machine is free on the 5th minute, it will start the operation on the 7th minute. And then for 4 minutes time, 7 plus 4 will become 11. Now guys, check this out. I have written here in this column idle time of machine 2. Idle time of machine 2 means for what duration machine 2 is sitting idle, doing nothing. So guys, for this first job, for these 3 minutes, when the job 1 was getting processed on machine 1, machine 2 was sitting idle. So I can say that for the first job, the idle time for machine 2 is 3 minutes. Then you can see that machine 2 was free on the 5th minute, but it got the job on the 7th minute. So machine 2 was again idle, doing nothing for 2 minutes in case of the second job. Now let me just move on to the third job. As you can see, after the 7th minute or on the 7th minute, job 2 is over. So I can start the third job on the 7th minute. 8 minutes is the processing time, so 7 plus 8 is 15. You can see that this machine, guys, you can see this. Yes, anybody has any doubt? I don't think so. Let me just proceed. So guys, now you can see that this job started on the 8th minute, and after 7 minutes got ended on the 15th minute. So this machine, the second machine, was free on the 11th minute, but the job came on the 15th minute, and 1 minute is the processing time. So 15 plus 1 is 16. And remember, for 4 minutes the machine remained idle. For 4 minutes the machine 2 remained idle. Okay. Now let me move on. So this will be 15 plus 3, 18. The machine was free on the 16th minute, but the job came on the 18th. So 18 plus 5, 23. Again 2 minutes of idle time. Next it will again start on 18 plus 7, 25. Guys, you can see the machine is free on the 23rd minute, but the job came late, 25 minutes plus 7, that is 32. So you can see again there is an idle time of 2 minutes. Now for this job it will start on the 25th minute. I am in trouble at the 6th. Don't worry, Ashwin. I am on the 6th. Don't worry. Just look at this. Look at this. So it will start on 25th. 25 plus 6 is 31. So now guys, see in this situation what is happening. In this situation what is happening? The job is ready to enter. The job is ready to enter here. But is the machine too empty? Is the machine too empty, guys? Is the machine too empty? The job is ready to enter, but is the machine too empty? No, it is not. So remember, when the machine will be empty, then only we can start the job. So 32 plus 2 is 34. 32 plus 2 is 34. But remember, in this case, the machine didn't wait. The job had to wait. So the idle time for machine 2 is 0. Now for the last one, this is 31, 35. So the machine is free on the 34th minute. So this is 35, 38. And again, I had to wait. The machine had to wait for 1 minute. So guys, I hope this is clear to you. This is clear to you. Up until this point, I have simply made a single table where I have kept a chronological sequence. A chronological sequence. Now with this chronological sequence, what I can see that 38 minutes is the total duration, total elapsed time, total time that got elapsed in this process where I completed all the 7 jobs on both the machines. So this 38 minutes or the total elapsed time is known as makeup span. Makeup span means, guys, total elapsed time. Makeup span simply means the total time, 38 minutes required to complete all the 7 jobs on both the machines. And you can see if you can calculate the idle time of machine 2, 3 plus 2, 5 plus 4, 9, 9 plus 5, 14. 14 is the total idle time of machine 1. Now guys, listen to me. Listen to me. Here I have simply used the chronological sequence because I want to explain something to you guys. Now what you guys will be doing, just look at this, and listen to me very, very carefully. I am going to be taking some names. So starting time of job 5 on machine 2. Starting time of job 5 on machine 2 is 31. No, Gopal Krishna Vasantha, no, it will be 32. Okay, on the 31st minute, although this job is completed on machine 1, but machine 2 is not free up until the 32nd minute. Remember, I can only start the job when the machine is free, and when the machine is running the previous job, I cannot start the job that I already have. Okay, so although this job completed on the 31st minute, I can only start the process on the 32nd minute. So guys, please be very specific when you are writing these times. Okay, just use your reasoning, use your analytical brain to do these, to write down these times. Do not memorize anything that this 31 will go here or 25 will go there. Okay, you just have to use the brain that whenever there is a situation when the machine is not free, then the job will have to wait. And whenever there is a situation when the job is not yet over on the previous machine, the machine will have to wait. The second machine will have to wait. Okay guys, so listen to me very, very carefully. Now what you will be doing, let me just use your names. So Arunopal Sanjay and Kurhadeji. What you will do, take this sequence, the number 1 sequence that is here, Arunopal Sanjay and Kurhadeji, take this sequence and make a similar table like this. Okay, now Ashok Kumar, Neelaj and Ajay, you guys make use of this sequence, the second sequence here, and make this very table. Okay, so Neelaj Ashok Kumar Ajay. Make use of this second sequence. Then Abhikrishnan Ashwin. Abhikrishnan Ashwin and Gopal. You guys make use of this sequence, the third sequence J4, J2, J5, J7, J6, J1, J3. So, guys, now you can all see the sequences on your screen. I have already taken your names. Just use these particular sequences that I have said and formulate the very table that I have just explained you guys to do. I will be taking this fourth part, the fourth sequence. I will be taking this fourth sequence and making the table for the fourth one. So let me just do that. Let me just do that. Meanwhile, you guys. So my sequence is the fourth one 4, 5, 2, 7, 1, 6, 3. 4, 5, 2, 7, 1, 6, 3. Very nice, Ajay. I mean, Ajay has some speed, man. Let us do. So for job 4, the timings are 3, 5. First sequence, please. 4, 2, 5, 7, 1, 6, 3. 4, 2, 5, 7, 1, 6, 3. So let me just write down the start time and end time. So 0, 3, 3, 8. So idle time machine 2, 3 minutes. 10. Although the machine is free, it will have to wait. Now the machine is busy. So 17. idle time is 0. So guys, have you all done yours? Mine is completed. Hello guys. Have you guys completed yours? 6 plus. Neelat, there is something wrong. There is something wrong with respect to the idle time. Just check your idle time. Arunopal is saying 230 makeup span 36. Arunopal, your answer is correct. Ajay, your answer is also correct. Ashwin, yours is also correct. So guys, has everyone done what I have told you? Hello everyone. Did you guys completed what I just asked you to do? Now guys, listen to me. Neelaj 32000016. Now yours is correct, Neelaj. Now yours is correct also. Gopal, it is span, not spam. Okay. Now listen to me, guys. Now listen to me. Guys, you can see what happened. No, Ashwin, idle time is not 13. Idle time is not 13. Ashwin, you have done something wrong. Just check out. Okay, just check out. You have done something wrong. Just check out. Okay. Now listen to me, guys. Listen to me. Guys, what I did when I took a chronological sequence, that is a sequence which was not provided by the Johnson's algorithm. At that time, my makeup span was 38 and the idle time on machine 2 was 14. But when we took the sequence provided by the Johnson's algorithm, the makeup span got reduced by 2 minutes and the idle time of machine 2 also got reduced by 2 minutes. So basically what Johnson's algorithm did, with the help of a sequence provided by the Johnson's algorithm, we optimized the makeup span. So guys, the sentence that I wrote, just check out the sentence. Johnson's algorithm reduces the makeup span and it gives optimal solution for makeup span. So what we did, guys, remember Johnson's algorithm job is to minimize the makeup span. We had 4 sequences and I specifically said that in the textbooks there will be only one sequence. I will tell you how to attain that one sequence. But all I am saying, I had 4 sequences via the Johnson's algorithm, and using all the 4 sequences, we formulated 4 different tables. You and I together, we formulated 4 different tables, and in every case, the makeup span was 36 and the idle time was 12. So guys, first thing you should understand that if a question like this ever came in the examination and it has been asked what is the makeup span, what is the idle time of machine 2 and whatever. Remember, you can go for any of the 4 sequences. All the 4 sequences are optimal. All the 4 sequences are optimal. Listen to me very, very carefully. I am saying all the 4 sequences are optimal. Now, basically, now let us try to understand what Johnson's algorithm is actually doing. Let us try to understand what Johnson's algorithm is actually doing. Johnson's algorithm said that if the minimum time is on machine 2, do that job in the very last, in the very end. And if the minimum time is on machine 1, do the job as early as possible. So basically, what is the intention of Johnson algorithm? Johnson algorithm is trying to put all those jobs which has a lower processing time on machine 1 as above as possible in the sequence. Johnson's algorithm want us to do those minimum processing time machine 1 jobs as early as possible. Why? Guys, check this out. Check this out. Whether I have formulated this table with the chronological sequence or I have formulated this table with an optimal sequence. Or I have taken this optimal sequence, in both the cases you can see machine 1 is always packed. Machine 1 is never idle because it is the first machine. When it will finish the job, then only the second machine can start. And as soon as the first machine is over with a single job, it will take the second job without wasting any time. So I can say the machine number 1 is always packed. Machine number 1 is never idle. Which machine is idle? Machine number 2. So what Johnson algorithm says, if you will do the small processing time jobs on machine 1, machine 1 will keep on providing the jobs to machine 2, and if higher processing time jobs are getting processed on machine 2, then in that duration, when a small processing time job came from machine 1, machine 2 is busy in the previous job which has a very large duration. So what happens? Machine 2 is still busy doing the previous job, the large job, the heavy job, and machine 1 is throwing away jobs. Do this job, do this job, do this job. That way, whenever machine 2 will get free, there is a job waiting outside the door and the machine 2 will have to do that job. So the entire idea of Johnson algorithm is to keep machine 2 as busy as possible. The entire idea of Johnson algorithm is to keep machine 2 as busy as possible. That means, guys, to reduce the idle time of machine 2. If Johnson algorithm can reduce the idle time of machine 2, that will simply reflect in the makeup span. And you can see in this case the makeup span was 38, the idle time was 14, and as we reduce the idle time to 12 by 2 minutes, the makeup span also got reduced by 2 minutes. Guys, I hope whatever I have just explained, you guys were able to grasp it. And if anybody has any doubt, just please, I beg, please ask doubts, man. Please ask doubts. Come on. Come on, guys. Come on. Anyone with any doubt? All I'm saying is the intent of Johnson's algorithm is to reduce the makeup span of machine 2. And how it is achieving that? By first processing shorter duration jobs on machine 1 and heavy jobs, long duration jobs on machine 2. Okay, That way, machine 2 will be busy with the previous job, and machine 1 by that time would have completed the second job and would have thrown that job to machine 2 in order to process that. So machine 2 will never have to wait. Okay guys, so I think it is clear. Everybody has written yes, it is crystal clear. Very nice guys, very nice. Let me just proceed. Let me just proceed now. So guys, now you can see up until this point we understood that all the sequences are correct. And why I have written four sequences? Because there was a tie. And where was the tie? Where was the tie? In between these two positions and in between these two positions. Okay. Study choice world. What is the class name, sir? Sequencing model to second class. Ajay is saying एक बार हिंदी में. Okay Ajay. No worries man. Why not? Why not? So अजय मैं ये कह रहा हूँ, ध्यान से सुन ले मेरी बात. मैं ये कह रहा हूँ कि जॉनसन एल्गोरिथम क्या बोलता है. जॉनसन एल्गोरिथम बोलता है कि भैया मशीन 1 तो कभी भी आइडल नहीं है. मशीन 1 तो हमेशा पैक्ड है. मशीन 1 जो है हमेशा पैक है. ठीक है ना. काम चालू किया, एंड किया, अगला जॉब उसके लिए रेडी है हमेशा. तो मशीन 1 तो कभी भी खाली ही नहीं है. मशीन 1 इज ऑलवेज पैक्ड. But when I will talk about machine 2, I have seen the instances when machine 2 is free. ऐसे कई मौके हैं जहां पे मशीन 2 जो है वो आइडल हो जा रही है. तो जॉनसन एल्गोरिथम का टारगेट है कि कुछ ना कुछ करके भैया मशीन 2 का आइडल टाइम को घटाना है. उसको वो कैसे घटाता है? बोलता है जितना भी छोटा छोटा टाइम वाला जॉब है, मशीन 1 पे जिस भी जॉब का टाइम कम है उस जॉब को पहले कर लो. मशीन 1 पे जिस जॉब का टाइम कम है उस जॉब को पहले कर लो. उससे क्या होगा कि अगर मशीन 1 छोटे छोटे टाइम वाले जॉब को करके देते चला जाएगा और मशीन 2 पे बड़ा टाइम वाला जॉब को पहले रख दो, तो मशीन 2 क्या होगा कि पिछला जॉब करते करते बिजी रहेगा, तब तक मशीन 1 जो है अगला जॉब फेंक देगा, और मशीन 2 जो है पिछला ही काम नहीं किया है तो अगला कहां से करेगा. समझ रहा है मेरी बात को? तो क्या है कि आइडिया इज, जॉनसन एल्गोरिथम का आइडिया है कि अगर कहीं पे छोटा टाइम दिखता है और मशीन 2 में है, उस जॉब को आखिरी में करो, क्योंकि मशीन 2 में तो बड़ा जॉब पहले करना है. और जहां पर छोटा टाइम दिखा मशीन 1 पे, उसको पहले कर दो. समझ गए ना. तो ऐसे में क्या है कि मशीन 2 हमेशा अपन कोशिश कर रहे हैं ज्यादा से ज्यादा समय बिजी रह सके. तो वही किया अपन ने जब यहाँ पे 14 और 38 का कॉम्बिनेशन था. जब जॉनसन एल्गोरिथम की सीक्वेंस अपन ने यूज किया तो ये 12 और 36 हो गया, और जो 2 मिनट हमने आइडल टाइम में बचाया वही अपने को 36 में रिफ्लेक्ट हो रहा है. ठीक है ना. ठीक है अजय, कोई दिक्कत, कोई समस्या? हाँ, यस अश्विन, द आइडिया इज वेरी नाइस. सो गाइस लिसन टू मी, लिसन टू मी, लिसन टू मी. Guys, listen to me, listen to me, listen to me. In order to check out these sequences, I told you guys that I had a tie in these two situations which I have encircled in red and green color. Guys, let me first of all tell you, there is no particular tiebreaker rule. Tiebreaker rule means whenever there is a tie, we try to break the tie with the help of a rule. So whenever there will be a tie like this, like same job, same time on two machines, there is no rule to break this tie. No rule for tie in this case. So same job, times are same on both the machines. You can either put 2 in the front or 2 in the back. It is up to you. So there is no tie rule here. But when there is a tie like this, similar times on different jobs, either job 6 can be processed first or 1 can be processed first. Okay. So there is a rule for that, and we'll be looking for that rule. So guys, what I will be doing, let me just step by step explain you Johnson's algorithm. So for the first step it says, examine the processing time on machine A and on machine B for all the jobs and find out minimum of AI and BI. So basically it is saying that just check out all the times of all the jobs and spot the minimum one. Okay. Now the step 2 is the large step. Okay, because there are variations in step 2. Now it says that if this minimum value is AK, if this minimum value is AK for some I equal to K, do the kth job first of all. कहता है, it says that if the minimum time is on machine 1, if the minimum time is on machine 1 for any job, let's say J1, if the minimum time is on machine 1, do the job in the very first. Do the job in the very first. Then it says if the minimum is BR for some J equal to R, do the job last of all. So if this particular minimum time is on machine B, we do that job at the very end. In case of tie for minima as AK equal to BR, in the case of tie for minima as AK equal to BR, process the kth job first of all, rth job last of all. Okay, so guys, check this out. We had a tie like this. We had a tie like this. We had a tie like this. We had a situation where there was a 3 here, there was a 3 here on machine 1 and on machine 7. Okay, so no, not on machine 1, for machine 4 and machine 7. Let me just erase this part. Okay, so there was a tie in between machine 4 and 7, but guys, this is not a tie. There is no such tie here because machine 4 is asking for the spot in the front, seat in the front, and machine 7 is asking for a seat in the last. So I hope you guys are able to understand. Okay, there is not a tie in this case because both these jobs are demanding different position. One is demanding the front position, other one is demanding the last position, so there is not a tie. So it says that if there is a tie as AK equal to BR, process the kth job first, rth job last. Then this is important, the tiebreaker rule. In case of tie in minimum values in same machine, say 2 minimum values in AI, then select the one with the lowest in BI first and process it first of all. Similarly, in case of say 2 minimum values in BI, then select the one with the lowest in AI first and process this job last of all. Guys, what it is saying, the case that happened here, there are 2 same values of 2 on the second machine for different jobs. Let me just write this here. Suppose guys, there is a situation, let's say this is job 1, job 2, machine 1, machine 2. So let's say this is 1, 2, this is 4, this is 2. So guys, suppose there is a tie like this. There is a tie like this where these 2 jobs have a similar time on machine 2 and both the jobs want to go at the last position. Both the jobs want to go at the last position. So what you will do, as I have said, both the sequences are correct. We have already proven that using the table and everything. But if you want to have a single sequence, suppose in some question in GATE examination, these 4 sequences are given and they ask you which is the correct option. Then what you will do? You will use this tiebreaker method. What this tiebreaker says, that if these machine 2 times are equal, select the one with the minimum time on machine 1. So select J1 and throw J1 at the last. Suppose there is a situation like this, machine 1, machine 2, J1, J2, 2, 2, 1, 4. So in this case, there is a tie between these 2 values on these 2 jobs on machine 1. And remember, these 2 machines are fighting for the front position. So it says that select the one with the minimum value of machine 2. So the minimum of machine 2 is on job 1. So this job will go to the front position. So guys, I hope this is clear to each and every one of you. Then the last line, if minimum value is same in both AI and BI for same job, then we can place the either first of all, last of all randomly, as this was the case here. 4 4 was the situation. I can place either 2 in front, 5 in back, 5 in front, 2 in back. So there is no tie rule breaker for that also. So there is only one way where there is a tiebreaker, and I have already told you that case. At the last, step 3, cross out the jobs already assigned, repeats the step 1, 2, 3 and then the jobs. So it basically says that keep on assigning and keep on crossing the jobs that have been allocated. So that's it, guys. That's it. We have completed processing n jobs through 2 machines. We have completed processing n jobs through 2 machines. This particular segment is over. I have told you everything there is at this particular topic, and in tomorrow class we will be going to start processing n jobs through 3 machines. Okay, in tomorrow's class we will be studying processing n jobs through 3 machines, and tomorrow is going to be the last class of sequencing model. And from Monday onwards I will be starting a completely new series on YouTube on the topic queuing models. Very important topic for the GATE examinations. Very popular topic also, very interesting topic also. So from Monday onwards at 9:15 p.m. on YouTube, I will be starting queuing models. Tomorrow is going to be the last class of sequencing model, where I will be discussing processing n jobs through 3 machines. So only one situation, one particular case is left. Sir, what about machine to tie? Ye kurhade, I have just explained the machine to tie situation. I have just explained. Select the one with the lower value on machine 1 first and do this job last of all. Okay. Whenever there is a tie on machine 2 in 2 different jobs, like here in case of J1 and in case of J6, there was a tie in case of machine 2. So it says these two, J1 and J6, are fighting for these positions, this backward position. So select the one with a lower value on machine 1, and the selected job J1 will go at the back. Okay, so that is what is the meaning of the tiebreaker rule. So guys, as I was saying, on Monday I will start queuing model, and tomorrow there will be a last class on YouTube for the sequencing model. We will be completing sequencing model. मशीन 2 के लिए लीस्ट तो लास्ट में होता है ना, मशीन 2 के लिए लीस्ट तो लास्ट में होता है ना सर. अरुणोपाल, आई एम नॉट एबल टू अंडरस्टैंड योर डाउट. मशीन 2 के लिए लीस्ट तो लास्ट में होता है ना सर. यस अरुणोपाल, लास्ट में होता है. यस. So guys, what I was saying, tomorrow we have a special class. Scheduled at 8:30 a.m. in the morning. Very important class. Let me just triple star mark this class. Transportation problem class. Okay, transportation problem. I have already completed transportation problem. There is one very important concept left in this particular topic. Very important concept, and I will be dealing that concept with the help of a question. And with the help of that question, I will not only be telling you the concept, I will also be revising the entire transportation algorithm. So guys, if anyone has missed transportation problem series, I have made 6 lectures. I think 5 lectures are there already. Tomorrow is going to be the 6th lecture on the special class. Every lecture is around 40 to 50 or 60 minutes. You can attend those lectures. And if you haven't yet, remember guys, tomorrow is going to be a special class at 8:30 a.m. on the transportation problem. In this class, I will be discussing a very beautiful concept, and also will be revising the entire transportation algorithm chapter. Okay, with that one question, in 60 minutes time only I will be covering this. And then after that there will be a second session. That will start at 9:45 a.m. that is about assignment problem. So I will be starting a completely new series on special class assignment problem. Guys, I am giving everything for free. Okay, nothing whatsoever. Although Unacademy has regulated, but I am trying to give whatever the content I can give to you for free, so you can benefit all the YouTube lectures, from all the YouTube lectures that I am making, as well as from all the special classes I am making. Guys, please ask your friends to attend these special classes. I must tell you that the interaction level on the Unacademy app is excellent. The total interface is excellent, guys. The way the interface works when a teacher writes, it is very smooth and everything. So it is far better than YouTube. Whenever I teach on YouTube, I feel extremely dull. I don't know why, but special classes are highly interactive because students can hear the session live. Here the number one situation is that there is a huge lag. What I am saying, you guys are basically listening that after 10 or 12 minutes, after 15 or 20 seconds. So there is a huge gap. 20 seconds is a huge gap. Whenever I want to ask you guys something, after 20-30 seconds, I will get the reply and I have to wait for that duration. And that is very annoying. So guys, it is better to interact on the special classes. Please come on the special classes tomorrow at 8:30 a.m. Make time for this special class. This is a very important class for transportation problem. We will be discussing the entire transportation algorithm via single problem, and then at 9:45 I will be starting the assignment problem series. So guys, that's it for today's session. That's it for today's session. And remember guys, I have said again and I am going to say it one more time that if money is not a concern, please go for the Unacademy Plus subscription. It is highly beneficial for you. I mean, not only you can watch live classes, you can watch crash courses, complete courses created by excellent teachers. And guys, remember there are different rank improvement batches where you can simply enroll, and there you can join batches with respect to whatever you feel like if you want to yes, Ajay, Subha. Okay, Ashwin, good night. So guys, Unacademy Plus is very beneficial. There are doubt solving classes. Every fourth class is a doubt solving class. Weekly tests are conducted there. Hindi and English is not going to be an issue for you. And you can join different rank improvement batches where you can simply enroll and get the notifications of the classes as well. And guys, remember, if you go for the plus subscription, use the referral code M10. This code will simply fetch you a discount of 10% across any subscription that you would want to opt for. Okay guys, so yes, that's it for today's session. I hope you like the session, and if you do, just please comment it in the comment box, like, share and subscribe this video. And if you haven't yet followed me on Unacademy app, just simply go and check out this link and follow me. You will get the notifications of all my classes. This is my Telegram channel. Take the screenshot of this link and then join through this link on the Telegram channel, where I will be daily updating my schedule as well as the notes and PDF of my lectures. So guys, thank you very much for joining this session. I will see you all at 8:30 in the morning and tomorrow at 9:15 p.m. on YouTube. Please like, share and subscribe this video. Tata, bye bye.